This is Algebra 1, Lesson 3b. We're going to be discussing circumference. So if you watched the last video, 3a, I asked, what do you call the perimeter around a circle? Well, this is your answer. You call it the circumference. So when we're talking about circumference around a circle, I'm going to draw a circle here. And my program helps me out a little bit, makes it a better circle. Circumference, just like that perimeter is around a polygon, usually, circumference is the distance around that circle. Okay, so it's kind of like the perimeter of a circle. And we know what a circle is. Okay, you can have a mathematical definition of it, the set of all points equidistant from a center. Okay, that center is going to be in the middle. You know what the center is. And that distance that the circle is from the center is called the radius. So the radius is this here, the distance from the circle. You probably have heard the word diameter. Okay, the diameter is also through the center, but it goes all the way through to the other side. Okay, so a diameter is really two radii. The plural of radius is radii, and if you have two of them, that makes the diameter. Okay, and then circumference, like we said, is going all the way around the outside. Now, it's kind of hard if you've ever measured the outside, the distance around a circle, because it's curved, right? If we were doing a rectangle, we can use our ruler and we can measure it, anything with straight sides. But with a circle, it's a little hard. You know, if you have a tape measure, that would work. If you have a string that you can wrap around it and then measure the string, that would work. I want to talk a little bit about Geogebra for a second. We're going to do a little demonstration where I can show you on the screen a little bit about circumference. So I have a circle here, and I can play around a little bit with the diameter of the circle. Okay, so I'm going to move the diameter down here to my ruler, and you can see that my diameter, the distance all the way through the center to the other side of the circle, it measures 1 centimeter. Okay, I can put that back up there, and you can see it is 1 centimeter. All right, I'm going to unwrap my circle. Pretty cool, isn't it? You can see that if my diameter was 1 centimeter, my circumference is a little bit more than 3. Okay, so if my diameter is 1, my circumference is a little more than 3. Let's see what we can do if we increase our diameter. So I'm going to move my diameter down here, and I'm going to use this to increase my diameter. Let's make it 2. Okay, now I'm going to unwrap it again. Let's see what we get. Okay, so a diameter of 2 gives me a circumference of a little more than 6. Let's take that back. Let's do one more. Let's make it a little bit bigger. Let's go up to 3. Okay, a diameter of 3. I'm going to unwrap it. Oh, I run out of room, don't I? So let me slide this over. Diameter of 3 gives me a circumference that is a little more than 9. Okay, so I'm going to make a little chart so you can look at these values and see if you can figure out the relationship between them. So here's my chart. If I had a diameter of 1, and that was in centimeters, the diameters are all in centimeters, and the circumference then would be all in centimeters. A diameter of 1 gives me a circumference of a little more than 3. A diameter of 2 gives me a circumference of a little more than 6. A diameter of 3 gives me a circumference of a little more than 9. So you can see there's a pattern there. As your diameter goes up by 1, your circumference is going up by 3. So let's think of it this way. What can I do to the diameter number? What can I multiply it by to get the circumference number? Well, I would say 3. 1 times 3 is 3, 2 times 3 is 6, and 3 times 3 is 9. But it keeps getting a little bit more and more each time. So it's a little bit more than 3. So it's like 3 point something. 3 point something, some number, right? And that 3-point sum number is a very special number, okay? And you can try this yourself. You can find a circular object. You can measure the diameter with a string, and then you could cut that string, and you could measure several other pieces of string that same length, and see how many diameters it would take to go all the way around your circular object's circumference. And you would find that every time it'll be a little bit more than 3 of them, which is really pretty interesting. I did this here. You can see my picture. I took a roll of painter's tape. I took a tape measure, and I measured around it, and I got a little more than 12, or a little less than 12, I think it is. Is it? Yeah. And then I measured the diameter of it, and I found out it was a little less than 4, okay? And if you notice that diameter, if you multiply it by 3 something, you would end up getting this number, okay? And I did the math out, and I could show it to you, but right now we'll just estimate, and that'll be fine. So looking on here in my notes, it's always, what are you going to be multiplying by? You're always going to be multiplying by a little more than 3. And if you measure with the tape measure, like I said, and divide the circumference by the diameter, you're going to always get that number next to 3. And I tell you what, it'll actually be this number, and you may have heard of this number before. It keeps going, it keeps repeating. You're going to get closer and closer to that number. And we find that number so often. Anytime we are dividing a circumference by the diameter, we're going to get closer and closer to this number. That number has its own special symbol and its own special name, and we call it pi. Okay, that's a Greek letter, and we write it kind of like this, and you'll see it on a calculator. Pi is an irrational number. That just means that it keeps going. See my ... here? That means those digits keep going. They never repeat, and they never stop. So that's what an irrational number is. Now, in math, that would really make it hard to compute. So what we do is we often round it to 3.14. And we use that to make it easier to work with when we're doing our calculations. So how do we use pi? Well, we've said that the diameter times pi, or that little more than 3 number, gives us the circumference. So that means circumference divided by the diameter is equal to pi, okay? So that means then that pi times the diameter will give us the circumference, okay? Remember how multiplication and division are reciprocal operations? So let me give you another little example up here. If I said 10 divided by 2 was equal to 5, then I would know that the reverse of that is true. 5 times 2 is equal to 10. So since our circumference divided by our diameter is equal to pi, then we know that pi times the diameter is equal to the circumference. And that's pretty helpful because remember we said circular objects are super hard to measure, right? So these formulas are very, very helpful for us. We don't have to use the string or the tape measure to measure the circumference. Now that we know about pi, we know that circumference is equal to pi times the diameter. That's our formula that we're going to use. Now, sometimes you don't know the diameter. Maybe you know the radius. Well, you know, because of what we said earlier, that if you know the radius, you can just double it, and that'll tell you what the diameter is, right? The whole thing is the diameter, and just this little piece here is our radius. So they often write the formula as well, 2 times the radius times pi. So 2 pi r is the same thing as pi times the diameter, because the 2r is equal to the diameter above. This times this is equal to this. Now, why do they split it and put the pi in the middle? Well, that's because this r is a variable, but pi is an actual number. Remember, it's 3.14159, and it keeps going. 2 is a number, and this r is a variable. And typically we're going to write our numbers before our variables, so that's why they split it and put 2 pi r. So now using those formulas, it can make finding the circumference a lot easier.